Every single thing that you see at Hack the Machine has something that is fundamentally relevant to what the Navy is going to do into the future. It is fundamentally relevant to how the Navy chooses to use and to deploy new technologies. Yeah, Hack the Machine is awesome.
In 2015, I was leading a cyber warfare research and development center for the Navy, and there were 2 young developers that worked there, and I asked them, hey, what are you thinking about Docker? And they just kind of made a face like, Docker? And it occurred to me that these young people are intelligent, bright, from great schools, and weren't current with the most topical current thing going on in all of computer science. And I realized we can assess the best, most creative people into government service, but if we aren't actively doing something to keep those young professionals connected with young professionals in the commercial technology ecosystem, there's going to be a drift between what the government is capable of doing and the cutting edge that's going on in commercial industry. And so I thought, we need to do something fun. How can the Navy have a public-facing Navy digital experience that takes a little from DEF CON and CES and the Blue Angels and smushes it into a thing that's uniquely what we've grown to try and create this community of practice around maritime digital and maritime cybersecurity challenges.
I love the structure of the 3 tracks in Hack the Machine now, because I really think those 3 tracks so tie into the newer majors and areas of study that we've cultivated here at the Academy in my last 19 years here. So you have additive manufacturing and 3D printing, which is very much related to my department, which is robotics engineering. We have the data science challenge, which really ties in a lot of things from robotics like AI, but also things from the math department, including statistics and computer science. And then, of course, the cyber operations major is so important to the Navy right now. I think it's so valuable for us as faculty members to have this connection to the outside world, to get real data, from the field on these real authentic problems that are important to the Navy. I can make up my own problem, or I can get something from a textbook, but often that feels contrived or dated. The fact that we're working with real data from the Navy on an important problem to the Navy, I think really, really engaged my students in the problem.
Hack the Machine allows lots of different organizations a focal point to do something that's very difficult to do in any other format. How do you take a challenge that people can understand both inside and outside in the service, crowdsource that solution seeking, and go from potentially thousands of ways you might solve it to 5 or 6 that actually look very promising, so that the science and technology budget of that program executive office or that major research program can say, these are promising techniques. Now let me seed fund the next stage of research. So we've gone from a macro, we could try anything, to these things look successful in a very rapid and inexpensive format for the Navy, to actually follow on work that accelerates the innovation curve, not just about ideation, but actually about application and delivery.
It's not just a bunch of geeks in a room. You have admirals there, you have decision makers there. These people can come in and say, here's this technology that I've heard about, right? Here's the thing that I've heard about. And they can actually see it being used. They can see people actually taking those technologies and making them better and improving them and finding a use case for them. And that is something absolutely incredible. That is an experience that you really can't get anywhere else.
This is going to be the 6th iteration of Hack the Machine. We've previously run it in San Francisco, Seattle, Austin, Boston, New York, and now running virtual because of everything that's going on in COVID-19. When I knew we were onto something was at the very first Hack the Machine, when a young lady from Snapchat and a young guy who was a coder from Facebook at Hack the Machine San Francisco came up to me and they said, we didn't even know you guys had cool problems. And we were like, yeah, we've got lots of cool problems. These are things that actually make a difference for the safety and security of people all over the world.
Well, last year when I attended Hack the Machine in New York, it was really the first time that I'd been there. And while I had heard some things, I really didn't know what to expect. I think some people might be perhaps intimidated by it, thinking they do or don't have enough technical skills, or they do or don't know enough about the Navy's problems. But what I really, really liked about it was just how inclusive it was. And I think that idea of having different people from different backgrounds attack the Navy's problems is so important, because certainly our adversaries don't know who or who isn't in uniform when it comes to the cyber realm. So we really need minds from all different backgrounds and all different application areas, industry, government, military, and so forth, just to come together as a team with some creative solutions to those problems. And I thought Hack the Machine did a great job fostering that kind of environment. I was really impressed with it.
Welcome to Hack the Machine. I'm Zach Staples, and I would like to welcome you along with our host, the United States Navy, that makes all of this possible. I won an award with some colleagues in 2017 from the Secretary of the Navy for the best innovation catalyst in the Navy Marine Corps. Our idea was Hack the Machine, and we are absolutely delighted that 4 years later, the event has grown to be the Navy's premier digital experience. It's international and accessible by people from all walks of life in today's virtual world. Let's talk about why you're here. Hack the Machine gives you the opportunity to use your skills in cybersecurity, data science, and advanced manufacturing. The Navy maintains many digital threads, interwoven to create national security capabilities for our nation and our allies. Hack the Machine is an opportunity to take some of the problems the Navy is wrestling with and crowdsource solutions where we can all benefit from your knowledge, and you can win prize money up to $15,000 for the first place in each track. There is also an opportunity for an up to $1 million contract for the third track that we're really excited to announce this year. Hack the Machine is your opportunity to take the skills and capabilities you've honed, developed, and learned throughout your life and combine them with your teammates to go up against some of the best in the country. I am the first to tell people who are new to Hack the Machine that the best teams are often comprised of the most diverse skill sets that you can imagine. Last year, Track 3 was won by a programmer, an engineer, and a school teacher. Our first Hack the Machine Track 1 was won by a combination of developers from a San Francisco startup, a few soldiers from the Army, and a lieutenant from the Navy. So keep this in mind today as you form your team immediately following today's kickoff. I encourage you to make new friends on Slack and build a competitive team to take home your share of $95,000 in prize money. Let's take a quick look at some of the challenges we've got queued up for you this week. Track 1 is maritime cyber. One of the things that Hack the Machine does is create a vibrant community of practice for maritime cybersecurity between folks in the Navy, professional pen testers, and those who want to learn more about improving the infrastructure that underpins global trade and the freedom of the seas. Behind me, you will see 2 games. The first is the Grace Maritime Cyber Testbed. This testbed is an integration of cyber monitoring tools and marine navigation and propulsion electronics, just like you would see aboard a workboat or a large yacht. The challenge is for your teams to play a capture the flag style game, scoring points first offline to qualify for a slot, then to use a virtual private network into an attack position on the testbed. The second game is called Crash. What do you need to know about Crash? It's all in the game. Crash will run a series of cybersecurity protections that we will activate a few days into the challenge. So early on, your goal is to crash the system using known vulnerabilities. After that, see if you can make the protections, see if you can make those same hacks work when the protections are turned on. This is going to help the Navy improve how we deploy cyber defensive technologies and allow you to be the first to go up against these technologies. Combined, these 2 games, Crash and the Grace Maritime Cyber Testbed, represent both information technology and operational technologies that are reflective of cybersecurity challenges the U.S. Navy faces, as well as shipping companies and navies around the world. Early on, I mentioned that Hack the Machine is a team sport, so I'd like to introduce the other half of my team, Nicole Mullins. Nicole helps drive the digital transformation at Naval Sea Systems Command, and I'm so honored to have you with us here today.
Zach, I'm really excited to be here today. Now, Hack the Machine is the Navy's premier digital experience, and I want to take a moment to let you know that this is different this year. It's different from 2019 on the Intrepid in New York, where there were hundreds of people together hacking overnight, to a completely virtual event for COVID-19. The digital skills and technology to accomplish this is impressive. And speaking of impressive technologies, we have to remember that cybersecurity is part of that, but not only that, artificial intelligence and machine learning are crucial technologies that we are using today. The application of these technologies is critical, in fact, to national security, now and in the future. Now, Track 2 jumps into a really interesting mix of natural language processing and the intersection of advanced machine learning and the COVID-19 pandemic. So we've gone through and curated a structured list of all the CDC recommendations that have gone out over the last year and created a game around labeling risk scenarios, understanding which rules apply to a particular situation, and optimizing the deployment of resources. So let's take the opportunity to gather everything that we've learned about how to deal with the pandemic and try to build decision support tools that will enable the Navy.
Nicole, you're absolutely right about the importance of data science, and I'm really excited to see how Track 2 shapes up this week.
Me too.
Let's jump into Track 3. This year, Track 3 is heavy metal, a hybrid virtual and physical challenge that allows the Navy to tap into a wider and more diverse base of advanced manufacturing in this country and beyond. Heavy metal offers you the opportunity to produce a metallic 3D printed part. Not only will you be asked to convert a 2D drawing into a 3D technical data package, but also to print and mail that part for testing and evaluation. This challenge is tied to a real supply shortfall, and at the conclusion of heavy metal, it could result in a contract up to $1 million to the winner. It all depends on how good those parts are. We'll be getting into all of the challenge details in just a moment. But before we do that, let's take some time to introduce the U.S. Navy stakeholders and commands that make all of this possible. Hack the Machine can bring relevant challenges to you because our naval sponsors are committed to this event producing actionable results. Over the last few years, the Navy has opened collaboration to more innovators and entrepreneurs. Here in Washington, D.C., the focal point for this outreach is NavalX, just miles from the Pentagon in Alexandria, Virginia. But no matter where you are, there is a naval tech bridge close by, and we'll be telling you a little bit more about this week. Hack the Machine started with an idea between the Naval Postgraduate School and the Naval Cyber Warfare Development Group in 2015. The Navy Cyber Warfare Development Group continues to be one of our most important sponsors. And for all of the Track 1 contestants that will be competing on the Grace Maritime Cyber Test Bed behind me, it's the Navy Cyber Warfare Development Group that makes this possible. Additionally, the Navy Cyber Warfare Development Group has sent a cadre of their engineers who will be penetration testing some games behind the scenes for new things that we want to roll out at the next Hack the Machine. And I'd be remiss if I didn't mention that the cyber warfare engineers are hiring. So if you enjoy these games, introduce yourself in Slack, and maybe you can turn your game into your day job. The U.S. Navy fleet is provided by two major organizations. In just a moment, we'll be meeting two of the leaders from Naval Sea Systems Command. But before we do that, we'd like to thank Naval Air Systems Command, who is the acquisition agency for the Navy's fighters, helicopters, and unmanned aerial vehicles. Protecting air systems from cyber attack is vital to national security, and we are excited to have Naval Air Systems Command's own Grace Aviation Test Bed here at Hack the Machine. Our on-site red teamers will be putting it through its paces, and you can compete against their records at the next Hack the Machine later this fall. The Navy's power begins at the shipyard. Submarines, warships, and aircraft carriers are the most complex machines in the world, and it takes an especially talented workforce to keep them fit to fight. We are honored to have the Norfolk Naval Shipyard as one of our sponsors for Hack the Machine this year. Over the last few months, we've been working with a team of internal change makers at the shipyard, or entrepreneurs, that have helped us develop Track 3 to solve that maintenance challenge I was talking about earlier. One of the things I love about Hack the Machine is that games like this have consequence and a real impact on national security readiness because of these collaborations. Partnering with the Norfolk Naval Shipyard has ensured that your work at Hack the Machine makes a difference for the fleet. Our keynote sponsor for this year is Naval Sea Systems Command. NAVSEA designs, builds, delivers, and maintains the ships, submarines, and aircraft carriers that make up the U.S. fleet. With me today is Rear Admiral Jason Lloyd, the Chief Engineer for Naval Sea Systems Command.
Hey.
Admiral, welcome. It's great to have you, sir.
It's good to be here.
It's good to have you. Sir, as the Chief Engineer for Naval Sea Systems Command, a you deal a lot with the hull, mechanical, and electrical systems that make the heart of the ship. But as we've seen, with the Grace test bed and in other places, we have increasingly computerized industrial controls that make that sophisticated system possible, as well as engineers that work for you are using digital design tools. Could you share a little bit of your perspective on how the introduction of computer machinery control and digital design tools are changing the way you think about what you do in your job?
Sure, Zach. So with the digital design tools, we've got to get away. We got to make sure we control the data when we build ships using model-based systems engineering. Huge advantage to us to make sure as we go through the systems engineering V that any feedback that we get gets fed back to the original OEM parts, and so that everything there is done quicker and more efficient. On the control systems, I started off my career on date myself on the USS Bainbridge, the nuclear variant.
I was on South Carolina, by the way.
Excellent. And so my first ship, there were very rudimentary controls and no digital gauges, which I'm sure you had the same thing.
Yes, sir.
And over my career, I've seen that change completely. And more automation become available, as well as less manning as a result of that automation. So my principal assistant tour was on the USS Nimitz during the fueling complex overhaul. One of the first instrumentation and control primary plant put on,
right.
And so saw a lot of advantages of that. And then my third sea tour, I was the first reactor officer on Gerald R. Ford. And Gerald R. Ford is an amazing ship. We used control systems for reactor plant instrumentation control, propulsion plant monitoring and control, machinery control monitoring system, and we were able to reduce the manning just in the propulsion plants by half from what's on a Nimitz class carrier because of the control systems, because we have those to help us think through things. The disadvantage that we always have to go deal with is on Bainbridge, we didn't have very many cybersecurity concerns. So as we go through and we develop these control systems, we need to be more and more astute in thinking about those control systems. Admiral Okano, who's going to be talking to you soon, she's really been trying to help me through this I'm a pure mechanical engineer, to explain what they've done through virtualization of the Aegis combat system, and how do we use that virtualization to go help us with more machinery controls so we can get quicker development, we can get quicker turnover, but still have great cybersecurity.
So that's really helpful. It sounds like with that computer control, you're able to reduce manning, have safer control of the plant, but then we also have to think through the cybersecurity challenge. So
absolutely.
So we're looking forward to getting back with you with anything we learned this week.
Okay.
I think one of the other reasons we were excited to have you on first is that your breadth as the chief engineer covers a lot of what we're doing here today. And as you install more advanced machines on your ships, you're also getting more feedback from those machines. And so what you do with that feedback matters. And I know that in the past, we did a data science challenge at Hack the Machine for you a few years ago that told you that you could do better on the data collection side, and you've got a program in place to start doing that now. But could you touch on how you deal with that data? What can we do with all that data that's coming back to us now that we didn't have before?
Absolutely. So we're good at collecting data. We need to improve in analyzing that data and using that data. We're doing a good job with the warfare centers right now. We've got used 6 years of digital data to build a gas turbine digital twin.
Cool.
We've been able to use that to develop a healthy engine model of that. And through numerous ships, we've gone through and we've proven that we can predict the failure of that gas turbine engine before it fails.
That's great.
So that's huge, because in today's day and age, both with rapidly evolving technology as well as the critical number of vendors we have going down, oftentimes the material is the long lead time in getting repairs done, right? So if I can use AI, ML with the data we're collecting, and the system you referred to as enterprise remote monitoring, if we can use that data and AI, ML to go analyze that data and tell me when I either need to do preventive maintenance or corrective maintenance. If it's corrective maintenance, I can order the long lead time part, I can have the work package developed. When the ship gets pierside, I can fix it, we can get back out and get rid of all that time down because we can't predict failure or get the long lead time parts.
Sounds like it keeps the fleet at sea and ready
Absolutely.
That's awesome.
Yep.
Another thing, like we said, like your job is big because it covers all of this. So we wanted to ask you about advanced manufacturing as well.
Okay.
So you and your advanced technology team in NavCO5 own the introduction of AM from that tech warrant perspective. It's a big field, there's a lot going on. I was just hoping you could share some of your focus areas for advanced manufacturing as you kind of try and weave all this together.
Yeah, absolutely. And again, I think all of this ties into Moore's Law and how quickly things are changing in technology and how we have to adapt our processes to get there quicker. And so I look at the additive manufacturing piece. First, I look at the quality piece. We've been doing castings, major submarine castings, ships castings for years.
Right.
And we used to do a whole lot more. We built 750 Liberty ships in World War II. So we used to do a lot more of that. Now we don't do as much. So you lose the art of doing castings. And so temperature control of doing castings, those kind of things, you can find defects in them. So it takes an art. And so my question is, why can't I 3D print that thing, right? 3D printing with metal to me is welding. You control, if you control the machine, and then you qualify the machine and qualify the process, then if you have problems while you're printing the casting, you can fix the problem while you're doing it, stop, correct it, and then move on. And then you're not finding things years down the road with non-destructive testing. So that's the quality piece. And then the really the schedule piece and cost piece is really directed to the metal track 3 that we're having today.
Okay.
Is I'm out at sea, I have a part fail, I need to be able to print that part as much as I can.
Right.
Because if I can, I don't need to store lots of parts that I may never use on the ship, cost-wise. Schedule-wise, I can print exactly what I need and get the whatever is broken right back out. So pushing in both that and that really addresses cost and schedule. And then the quality piece for building additive manufacturing type things.
So that's exciting. You got a lot going on.
Absolutely. Good stuff.
Well, I tell you what, you covered 3 things. Some of our concerns about industrial controls and maritime cyber. We talked a little bit about data science, and we also talked about advanced manufacturing. I think there's a lot of people competing on all 3 tracks that agree with you that the Navy can do better and go faster. And so we'll be back to tell you anything we learn. And I wanted to thank you for helping us kick off.
Yeah, thanks to everybody else. Continue to think out of the box and bring us up to speed where we need to go.
Yes,
thanks,
sir.
Zach.
Thank you.
Appreciate
We'll catch up later.
Have a good day.
As you heard, Admiral Lloyd has, as the Navy's chief engineer, a span of responsibility that covers all 3 of our tracks. So we're so grateful to have him on the stage with us today to discuss that. Because what you do matters, and these 3 tracks have direct applicability, and you heard him. I mean, he wants to go faster. He thinks 3D printing in metal is advanced welding. I know a lot of people out there agree that it can be doable, so let's show them that as we work through these complex engineering problems. Nicole, that was pretty inspiring as a way to get started across the whole thing, wasn't it?
It absolutely is, and it's a very different look on how we can do things at the ship without bringing it back on the yard. So I'm super impressed, and I'm excited to see what we come out of with Hack the Machine.
Me too.
But Zach, a ship's just a ship until you actually add the radar, the sonar, and the weapon systems that turn it into a U.S. naval vessel. Today, we're honored to have Rear Admiral Seiko Okano, who is the Program Executive Officer for Integrated Warfare Systems, responsible for the capabilities that turn a ship into a warship. Welcome, Admiral Okano.
Hi, Nicole. Can you see me and hear me? Okay.
I can hear you just great.
Okay. Can you see me?
Somebody can see you. You're great. I hope you're having a wonderful day there at PEIWS. I know we keep you hopping.
You keep me rolling. You keep me rolling.
I'm thrilled that you can be here with us today. So I wanted to ask you, based on everything that you're doing within IWS right now, what can you tell us about who is involved with data science within the Navy?
So look, we don't have enough data scientists in the Navy right now, and that's something that hopefully this track will help us with. We need more. The Navy's just embarking on this AI journey, and so we've got to build that community to help us along that track. We need better data science faster for our sailors and Marines to help them make the best decisions in a highly adaptable and changing world. the environment that those sailors and Marines are operating in is just changing so fast. And so we have got to really make sure that we give them the right decision aids going forward.
So taking that into consideration, because those decisions are so vital and the timeliness of them, how do you see natural language processing and the decision support tools at work for the Navy, specifically with IWS and what you're doing there in the combat systems as well?
Yeah, so in my organization, we build the combat systems and we build the decision support systems for the sailors to operate. They're operating with concept of operations that's written in a natural language. And so how do we help them with those decisions? We're really interested in that natural language processing. I think the challenges that we're giving in track 2 is really to have the folks get a data set, it's the COVID data set, but build a recommendation engine from that data set and see if we can understand the risks of those various scenarios to make an informed recommendation, going forward. And hopefully that translates to, can we use that in our world to make good recommendations for those sailors in the environment that they're operating in.
Excellent, excellent. Now, we talked a lot about doing things in a very digital way, but Admiral, we have contestants who are watching today that might be wondering how the U.S. Navy intends to approach all of this digital and integration with artificial intelligence with ethics. So can you give those viewers a preview of how Hack the Machine might be helping the Navy crowdsource some of those important sensitivities?
Oh my gosh, great question. So, we take AI ethics very seriously, and in order to do that, we've got to push this problem forward in a very responsible way from the ground up. So in track 2, we are giving bonus points for people providing, the analysis and that ethical framework. So we want to have the discussion on that to make sure, we're doing this right. I mean, the idea of AI and weapon systems for people is scary. I mean, it's scary for me. So we've got to do this right. And certainly we need to help the humans make the decisions and not just, go for the Skynet.
Excellent point, excellent point. All right, so thank you so much for your time here, Admiral Okano. And I know that you were doing incredibly initiative things over in PUIWS. So whatever we learn from track 2, I'm sure we'll get back to you over there. And it's really been an honor having you here today. Hopefully we'll talk to you again.
Absolutely, Nicole, thank you for everything. I don't know if everybody knows, Nicole helps us out in IWS and with our digital transformation. So it's very fitting that you're hosting this, but thank you for everything you do for us, Nicole.
My pleasure.
Nicole, that's exciting. It's good to hear how Admiral Okano is pushing the science, but doing it in such a thoughtful way.
She is, and I appreciate all of our senior leaders coming up here and really applying not only their own time and their own thoughts into what's normally thought of as other people's jobs. So that's really great to see their engagement.
All right, so far we've heard about Hack the Machine's intersection with Navy engineering from Admiral Lloyd and mission systems from Admiral Okano. But a ship that can move and fight still has to communicate. And in the Navy, the organization responsible for delivering this capability is the Naval Information Warfare Systems Command. We're honored to have Rear Admiral Kurt Rothenhaus joining us from their headquarters in San Diego. Admiral Rothenhaus is the Program Executive Officer for Command, Control, Communications, and Intelligence. And he's also the Program Executive Officer for Space Systems. Admiral, good morning to you, sir. How are you?
Hey, good morning, Zach. How are you?
Hey, sir, how are you doing? I think we've got you up now.
Terrific. Hey, it's great to be here. Good afternoon and good morning from San Diego and from the engineers, scientists, and other professionals here at the Naval Warfare Systems Command and PEOC4I. We're really excited to be here and be with you folks today.
Admiral, you and I worked together for a while, so I have a pretty good feeling for what you do. But I just read off a lot of words. I actually said everything C4I is, et cetera. So tell us a little bit more about NAVWAR and specifically what you're doing as PEO C4I and PEO Space Systems.
Well, thanks, Zach. Great question. And before I kind of kick off a little bit of that, I want to thank you and the whole team for pulling this together. These events are just tremendous. We learn a lot. We're inspired by the work you folks do, and of course the contestants. And so we're really excited. And thanks to our fellow sponsors there too, at the Naval Sea Systems Command, Naval Air Command, as well as my fellow PEOs. It's just great to be here. As you articulated up at the beginning, we enable the communications for our ships, submarines, and aircraft around the globe. We also support the computing platforms so that we can facilitate those communications and sensors and intelligence, command and control, as well as various other supporting things like logistics, the ability for our sailors and Marines out at sea to be able to order parts, be able to sense the battle space, predict the weather, a whole series of things and technologies that we bring together and then deliver to those platforms that Admiral Okano and Admiral Lloyd highlighted. So we're proud partners along with them to deliver those systems to our sailors and Marines at sea.
Sir, thanks for that. You've been a great supporter of Hack the Machine for several years, and one of the things we say about Hack the Machine is that we're building a community. So I actually want to ask you a little bit about that. Can you just share with us some of the benefits that you have seen from crowdsourcing national security challenges like this?
Yeah, thanks, Zach. I'm a huge fan of Hack the Machine. We learned every one of these events, we've learned a tremendous amount. One, we get exposed to new ideas. We get exposed to new concepts, technologies from the contestants, and the folks we send to participate really get energized and inspired by the interaction. So it's a terrific event. Some of the things early on that we learned at some of the previous events, as we started to embark on adding technologies to our compute stack to more rapidly support DevOps and the ability to move data on and off the ship and update the system, we learned a lot from the Hack the Machine. And we actually had some folks in some of the contestants there continue on and do work with us in other fields. So not only was there an opportunity to learn from these folks, but I think we were able to get some team members on to join us out here in California and work on these challenges full time. So it's just been a tremendous opportunity to share innovation and learn from folks and bring a better and stronger and more diverse workforce from across the country together to look at these challenges.
Sir, I appreciate that. Maybe if we can dive into that just a little bit more. I think a lot of folks who don't know much about the Navy, I joke around, they think it's all short hair and push-ups. I obviously forgot the short hair part over during COVID. but in all seriousness, there are great opportunities to do exciting work on the government team. And I know we're hiring across all of the PEOs that we talked about. And we believe that events like this refresh the government workforce skill set. But can you talk about some of the opportunities there to be on the government team, and if people really enjoy what they're doing here this week, how they could continue to do that in a couple different ways?
Thanks, Zach. It's a the Navy is really fortunate to have a group of scientists, engineers, and other professionals dedicated to building, designing, and delivering the systems that we put to sea and our sailors and Marines count on. And so there's numerous laboratories around the country that do this work and specialize in different areas. And so for the contestants out there, there's an opportunity to meet and talk with those folks. And you can hear folks who are working on those cyber challenges, folks that are working on intelligence systems, folks that are working on command and control or weapon systems, and really get a sense of the terrific work that those folks and those patriots do every day. We also benefit from a very robust industry partnership. We're just both the commercial sector as well as our defense partners. Many of those folks work tirelessly to deliver the systems that we put to sea. And so an opportunity there to join those industry partner teams as well as the government team and continue to work on these challenges. As a nation, we learned so much from the commercial sector, as well as the defense partners, as well as these laboratories and academia. So across the board, just that synergy of all those different relationships gets us the opportunity to deliver better outcomes for the sailors.
Oh, sir, well, thank you first for your technology leadership and then secondly for being such a leader and team builder across so many different communities. We're gonna run the games. We're gonna learn a lot this week, and we'll be out there to San Diego here soon to give you the update, and we'll know you'll do something important with it. Thank you.
Hey, thanks, Zach, and good luck to all the contestants.
Thank you, sir. Well, it was really interesting to hear Admiral Rothenhaus make a point about team building and how the Navy team is so broad. It's uniforms, it's government civilians, it's traditional defense contractors, it's non-traditionals, it's innovators and entrepreneurs. I mean, it's a big capability.
The Navy really does subscribe to the idea that we need all to work together to get it done. I mean, it's not just one, it's not just someone in a particular uniform. And I'm actually really looking forward to seeing what the teams can achieve this year at Hack the Machine, because teamwork is vital and is so important to what we're doing. So when we think about some of the amazing public and private teams, the moon landing often comes to mind. And though we always think of NASA, America's aerospace companies shared in that success. What's special about Hack the Machine is the interaction and engagement of our community partners. All of these companies are existing providers of technology that the Navy uses. So including their technology and insights in the gameplay this week makes the challenges all the more relevant. Now, we have subject matter experts in Slack, that is our official communications mechanism, that will be joining us on the daily briefing tomorrow and Thursday, as well as noteworthy discussions from these community partners about their work with the Navy. So see the agenda for their sessions at HacktheMachine.ai. Now, Hack the Machine is powered by Fathom 5 and Booz Allen Hamilton. You've already met my co-host, Zach Staples, CEO and founder of Fathom 5. Tomorrow, you'll meet our colleagues at Booz Allen Hamilton. They are the prime contractor supporting the Department of Defense's Joint Artificial Intelligence Center. Speaking of artificial intelligence, you'll want to check out Thursday's session with Monica DeZaluda of Microsoft on quantum-inspired AI. Now, supporting your team on Slack and our subject matter experts from NVIDIA, who are one of the primary providers of machine learning hardware to the Department of Defense. We are also joined by FireEye, who provides cybersecurity services to the Navy, and will be discussing specific industrial cybersecurity lessons learned that apply to Navy machines. HackerOne is a leading organizer of ethical hackers that have found thousands of shortfalls in Department of Defense systems, and they will be sharing their insights on hacking for good. Want to 3D print on metal from your hobbyist printer? So then you'll want to turn into Matter Hackers discussion on Wednesday about new filaments that make this possible, and a discussion of the knowledge and skills to enter the advanced manufacturing workforce. All right. So are you ready to hear about how to compete for bragging rights and cash prizes to win Hack the Machine this year?
I know I am.
Me too.
Let's get into it. Hey everybody, we're going to jump in and give you the track descriptions now. Our track 1 lead is Dr. Dave Burke, the chief engineer at Fathom 5. Dave is one of the foremost experts in Navy cybersecurity, and he's going to introduce you to a really exciting set of games. Dave, over to you.
Good morning, everyone. I'm Dr. Dave Burke. Today I'm coming to you live from NavalX in Alexandria, Virginia, as the lead for Hack the Machine Track 1, Maritime Cybersecurity. The goal of Track 1 is to provide an opportunity to get hands-on with the actual equipment, even if it is virtual in a global pandemic. This year's Hack the Machine Track 1 is running a total of 6 games. We have 4 games, Digital Manufacturing Environment, or DME Inside Out, and DME Outside In, Aviation Grace, and Grace Downrange, which are available for limited in-person red teams, but are not part of the competitive Capture the Flag event, otherwise known as CTF. We'll be providing updates on the action of these games throughout the week. Our 2 virtual games, Maritime Grace and Crash, are part of the virtual CTF event. These 2 virtual stations stress different cybersecurity skill sets, from information technology to operational technology. I am really excited about this opportunity to provide this virtual competition, and I think it's going to be a really fun event. Now let's talk about each of the games in more depth. Maritime Grace is the operational technology game for this CTF. Grace has a full range of maritime bridge electronics configured how you might find them on an actual ship. These are running NMEA 2000 and CAN bus messages across the OT network on the Grace navigation and propulsion consoles behind me. The competitors will have an opportunity to reserve a time slot on this laptop where they will be able to interact with the NMEA and CAN bus network to launch malicious attacks to score points. Can you take control of the rudder? Can you spoof the navigation system? Can you take control of the throttle? Here's your opportunity to prove it. But first, your team will need to qualify on an offline NMEA 2000 packet capture challenge that will be released at the beginning of the competition. After you have qualified by earning 1,200 points in this offline challenge, you will then receive a link to sign up for a time slot to launch attacks and score points during the online challenge at NavalX. Now I want to tell you about the other virtual game, a game called Crash. Crash is our information technology component for this CTF running on this set of servers is a collection of purposely vulnerable applications protected by a commercial cyber defensive technology. This commercial technology solution combines deep application awareness with automated runtime protection technologies in a single smart agent. It monitors file integrity, memory usage, and interpreted as well as compiled code execution to detect and protect against even unknown attacks, malware, and unauthorized changes, preventing workloads from being compromised. That's their claim, and you are putting it to the test. Each team will score points for demonstrating successful attacks against the unprotected applications during the qualification round. Then there are a huge number of points available if your team can bypass the defenses on the protected applications. To make this even easier, we are going to give you the virtual machine images for the unprotected applications so that you can spend the initial part of the competition racking up all the exploits you can against them. At 12 p.m. Eastern Time today, a link to a repository where you can download the VMs will be shared at the launch of the competition on Slack. When you're ready, you can schedule time to come demonstrate all of your attacks against these unprotected applications for the Track 1 judges. Then, once you have demonstrated at least one remote code execution attack, you can sign up for a time slot to try your hand against the protected versions of the same applications. Not only are these games fun, we have some real money available for the winners. The first place team will walk away with $15,000. The second place team will walk away with a cool $10,000, and the third place team receives $5,000. Additionally, the first place team will be invited to join the live awards event on Friday. Your score will be the sum of your team's performance on both the Maritime Grace and Crash games. We are running these stations concurrently, so I highly recommend that Track 1 participants form up into teams of between 5 and 10 individuals so you can divide and conquer between these two stations. If you aren't on a team, or if you have a team that has room for other folks, a great place for you to start this event is in the Team Building Track 1 channel on the official Hack the Machine Slack workspace. My staff is going to monitor this channel to help get folks organized into teams. You can join the workspace with the Slack invitation link sent to the email you registered with. If you have not received this email, first check your spam junk box. If you still cannot find the link, please reach out to us at hello@hackthemachine.ai. Also on Slack, there's a dedicated channel called Track 1 Maritime Cyber. My staff will be utilizing this channel to coordinate the CTF and to answer any questions. The Track 1 participation guide covers all the information on both Maritime Grace and Crash games in a bit more detail and is already available on that Slack channel. Now let's go over the Maritime Grace testbed in a little bit more detail.
Good morning. I'm Anthony Connor, cybersecurity researcher at Fathom 5, and this is the Grace Maritime Cyber Testbed. The left side console here is a navigation console. It has many of the maritime electronics that you would find in a commercial workboat or even a large pleasure craft. The center of this console is the electronic chart and information display system, also known as the ECDIS. The left-hand side of the ECDIS here is showing the charts with navigable waterways, and on the right-hand side, it shows the speed through water, heading, and the rudder angle, just to name a few. This is the display where many of the cyber attacks will create visible effects, and so will be live streamed throughout the CTF event. We will try to notify contestants via the Slack Track 1 channel whenever interesting effects may be seen on the ECDIS feed. The ECDIS is connected to the NMEA 2000, which allows connection to the network and to other sensors and components on the console. Now to the left of the ECDIS, we have the autopilot display from which we can control the rudder on the top, and to the right of the rudder, we have the speed through water sensor. The speed through water sensor is engaged with the brush wheel that is part of the Grace simulation framework. The simulation framework will spin the speed through water sensor and provide other data to the NMEA components, tricking them into believing that they are operating on a real vessel. And for this simulation, the vessel is off the coast of San Francisco. Just to the right of the ectus is the weather station and an actuated gimbal. In addition to atmospheric data such as wind direction and barometric pressure, this weather station also provides magnetic heading along with pitch and roll. The right-hand console is set up as a fly-by-wire propulsion system. The components on this console are communicating via CAN bus messages, which can coexist on the MIA 2000 and on that same physical OT network. This propulsion system is comprised of 5 components: 2 throttle stations, a control unit, a shift unit, and a throttle actuator. Now, the lights to the right of the shift unit indicate the transmission position being set by the shift unit. Now, as you can see, when I move the throttle in the forward position, the green light indicates we're in the forward gear. When I shift back to the middle, the yellow light indicates we're in the neutral position. And as I move the throttle backwards, the red light indicates the transmission is in the reverse gear. Now, if I move the throttle further in the reverse direction, or if I move the throttle forward, the throttle actuator will respond accordingly. The reason this throttle system has 2 stations is to simulate a vessel with a lower bridge and a flying bridge. This setup would allow an operator to transfer control from one bridge to the other, and this presents yet another possible cyber attack for the system. Now I can release control from this throttle station, and then I can take control on this throttle station, like this, and now this is the device that is active throttle station. This is a quick overview of the components on the Maritime Grace game, and I will be the primary judge for this event. And I look forward to working with you all as you try to compromise the system.
Thank you for participating in this year's Hack the Machine, and I wish you the best of luck.
Wow, that sounds like a real challenge. Now, I'll be following track 2 and the data science challenges. For more on how the game will be run, we have Monica London, a Fathom 5 data scientist.
Good morning, everyone. My name is Monica London. This morning, I will walk you through the 3 different challenges of Hack the Machine's Track 2 and all of the logistics you need to know to have a great week. Just like with Track 1, Slack will be the official communication channel for Track 2 and is where you will receive all updates, can ask for help from subject matter experts, or just ask general questions. You can join the Slack workspace from the link you received yesterday via email if you have registered for the event. If you've registered for Hack the Machine Track 2 and have not received this email, first check your junk or spam inboxes. If you do not find it, then please reach out to hello@hackthemachine.ai. Again, that is hello@hackthemachine.ai for further instruction. Now, let's talk about teams. You can check out the Team Building Track 2 channel on Slack and form a team there. We think the ideal team size is about 3 to 5 people. There's a spreadsheet posted in Slack where you can fill out your name, team name, and GitHub username. You will get placed into a private repository that no one can see except the admins in your team. Here, you will receive all the data, submission instructions, and READMEs. The READMEs and data will be dropped into your GitHub repo at 12 p.m. today. There is also a link posted in Slack to the participation guide, which contains general instructions and information about the challenges. Each evening at 5 p.m. Eastern, your Challenge 3 submission for that day needs to be in the submission folder as a CSV in the following format. We will run a script that grades your results based on what's in the submission folder. If it is titled wrong, GitHub will not accept it in the folder. Challenge 3 will have new data released each day at 5:30 p.m. in the data folder. Challenges 1 and 2 and Challenge 3 Day 3 CSVs need to be in your submission folder by Thursday at 5 p.m. The subject matter experts, or SMEs, are here to help you. When you want to Zoom with a SME, you can sign up for a 10-minute slot on the SME sign-up form that will be posted in the Track 2 Data Science Slack. This is where you can get help from world-class data scientists if you're stuck. Please note that your team is limited to 1 10-minute slot per day. Challenge 1 is the Spectrum Labeling Challenge. In this challenge, you will develop an algorithm that most accurately labels scenarios on a scale of 1 to 6, with 1 being completely safe to 6 being extremely dangerous in terms of COVID-19 risk. For example, a 22-year-old college student would like to go to a beach party with their friends. The party will be in the open air with direct sunlight. Masks are not required. Drinks and food will be provided and served in a shared family meal context. The correct label of this situation would be a 3 on the spectrum of safe to dangerous. A correct guess of 3 would be awarded 2 points. A margin of error of 1 point will be allowed for this challenge. If you guessed 2 or 4, for example, you would win 1 point for that scenario. Challenge 2 is the Dangerous Situations Challenge. Having rules that can help individuals navigate the world in a pandemic is a valuable tool that can prevent unnecessary spread of viruses. This challenge asks you to use the CDC's extensive guidance on COVID-19 to make adverse scenarios easier to navigate. Different situations require different actions. What is safe for one person may be disastrous for someone else. By determining which guidelines to change or eliminate for a specific scenario, we can deliver tailored advice about controlling the spread of the virus at all times. You will be using the CDC's guidelines to modify interactions for adverse scenarios. Your challenge will be to create a union set of the standing rules and supplemental rules for specific scenarios. You will be assigned points based on your ability to replace and modify the general rules with the rules you have parsed from the CDC data. The CDC's recommendations on how to minimize the spread of COVID-19 will be in the data folder in your GitHub repo. This dataset contains information about the virus and preventative care measures. For example, if a standing rule for everyone is wear a mask, then a supplemental rule for a person traveling may be wear a mask over your nose and mouth when in public settings. Masks are required on planes, buses, trains, and other forms of public transportation traveling into, within, or out of the United States and in the U.S. transportation hubs such as airports and stations. Now, let's talk about Challenge 3, Optimizing Resources. Challenge 3 works a little bit differently than the other 2 challenges. The ability to correctly allocate medical resources is a valuable tool for promoting the health and safety of sailors on Navy ships and ashore. This challenge uses time-release data about an outbreak of COVID-19 on the fictional ship, the USS Ghost. The USS Ghost is stocked with medical supplies to combat the virus. We want you to develop an algorithm that can correctly allocate medicine, medical equipment, and hospital beds to sailors if they become ill. The scenario progresses daily, and the reports with the number of sailors with COVID-19 and the rate of decline in their health will be made available to you in your data folder each evening at 5:30 p.m. Eastern. To support the health of the crew, you must allocate resources including ventilators, beds, oxygen tanks, and cutting-edge medical treatments to keep as many crew members as healthy as possible. In a real-world outbreak, each treatment allocation decision would be made by a qualified medical professional who would take appropriate ethical considerations into account. For this challenge, the purpose of your algorithm is to develop a schedule and recommend treatment that is purely statistically driven. The most important thing to remember about Challenge 3 is that you will need to submit your results for the day each evening by 5 p.m., and then new data will be provided to you. Final submissions for all of the challenges are to be submitted through GitHub on Thursday at 5 p.m. By 9 p.m. Thursday night, we will announce the top 5 teams on Slack and via email based on the results of our automatic grading script. We will then ask those top 5 teams to join us for a 15-minute Zoom call between 8 and 9:30 a.m. Eastern on Friday morning, where we will verify your model and allow you to present your solution and the reasoning behind your approach. Final winners will be announced on Friday during the live show. The first place winner will receive $15,000 and will have the opportunity to join the show. We are very excited for you to participate in Hack the Machine Track 2 Data Science. Please reach out to us on Slack if you have any questions.
Nicole and Monica, I am really looking forward to hearing how Track 2 develops. So let's turn our attention for a moment to Track 3, Heavy Metal. With us today to introduce the challenges are Samantha Snabbs and Matthew Fiedler of Re3D.
Welcome to Heavy Metal, your chance to flex your 3D printing muscles in one main competition and 2 bonus challenges during Hack the Machine. We call the main challenge Light It Up. This challenge, if you choose to accept it, is to create a TDP, or a technical data package, and a real-world metal part from requirements provided by the Navy. This event will utilize your 3D printing expertise and innovation and metal 3D printing resources to create a light fixture bracket.
So how does this really work? As you may have heard, the Navy recently approved the requirements for additive manufactured parts using the powder bed fusion process. This is a great first step that helps the shipyards return vessels to service quickly, but it is also true that other metal additive manufacturing processes may be used to produce metal parts to repair the equipment our warfighters depend upon. In order to cast the net even wider, we have opened up this challenge to include any additive manufacturing process that produces a metal part. Contestants in this challenge will be asked to create a light fixture bracket from a family of parts that is used on board a naval ship. The bracket is a real-world part that connects the light fixture to the light stanchion. Samantha is holding an example piece that was printed in plastic on a Gigabot 3D printer. The bracket measures 220 millimeters in length and width and 38 millimeters tall. The part was originally produced in 1974 and was made from an aluminum alloy. For this challenge, you can use any metal alloy of your choice. Starting today, we will give you access to the 2D drawings of the light fixture bracket, and you will have 2 weeks to create a piece and send it to us for evaluation and testing. Each team is allowed to submit only one piece for judging. In addition to submitting the printed piece, you will also submit a technical data package that outlines the material and the process you use to create the part. Once we receive the part, we will be inspecting it for both dimensional accuracy and fitness for duty. We will check several key measurements to ensure that the part will physically fit the light fixture. Next, the part will be vibe tested to ensure that it can withstand the normal vibrations encountered on board a ship. And finally, the top 3 parts will be subjected to the mil-spec 901E lightweight shock test. Entries will be judged and awarded points in the 4 categories. Number 1, the technical data package. Do you have a clean and concise document that is well laid out? Number 2, the part qualification strategy. Are you using a novel approach? Are you paying attention to material qualifications, machine and process qualifications, and ensure traceability and quality? Number 3, part testing. Is the part built dimensionally accurate? Can it withstand vibration and shock testing? And finally, number 4 is the judge's discretion, which will be 10% of the score.
Thanks, Matthew. Well, let's talk about what people really want to know. The huge prize at the end. The winners of the Light It Up Challenge will receive $5,000 for third place, $10,000 for second place, or $15,000 for the grand prize winner, who also receives the potential for a $1 million follow-on contract. That's right, $1 million. Now, we understand that not all participants may have access to a metal printer and/or might not be able to produce a part in such a short timeline. So for this reason, we're also hosting a bonus challenge for an Inspiration Design Award. Beginning at noon Eastern, you can access requirements to produce the official Hack the Machine Challenge Coin. Now, for those of you that aren't familiar with what a challenge coin is, Matthew has a challenge coin provided by the Marines for reference. Now, design requirements can be accessed, and completed designs can be uploaded on a tool called Turbo TDP. More to come on what that means in just a couple of minutes. Coin designs should be no larger than 2¼ inches in diameter and 1/4 inch thick. Now, feel free to use any style cues from the Hack the Machine website, as well as your own creativity. However, as the executive agent for Hack the Machine is moving from the Naval Sea Systems Command to the Office of Naval Research, the coin should reflect a partnership between these 2 organizations and their ability to jointly collaborate with a broader maritime digital community of practice to drive innovation. Once posted, the entry will be highlighted in Slack, where every participant will have the chance to vote for their favorite entry by adding a reaction. So what this means is that those people that upload their entry first will have more time to collect votes. Votes and submissions will be collected until 12 noon on March 25th. Then the top 5 entries will be judged for printability, novelty, and compliance with requirements. The winner will be announced on March 26th, and in addition to printing the challenge coin and mailing it to the first place awardee in metal, they will also receive $5,000. Finally, a third bonus challenge called the Turbo TDP Scavenger Hunt for a t-shirt, swag, and bragging rights is now live. Instructions will be posted in Slack, and the first person to solve the scavenger hunt and answer questions about Turbo TDP will be declared the winner. So what happens next? All three of these challenges involve creating an account to use a government tool called Turbo TDP. Instructions to create an account are posted in Slack. Once you enter the site, you will see a product titled Light Fixture Bracket, as well as a product titled Coin Challenge. Both of these products have documentation needed for the Light It Up as well as the Design Inspiration Award.
So to recap, instructions to create a Turbo TDP account will be available on Slack. Slack also has the instructions for the Turbo TDP scavenger hunt, the first correct scavenger hunt answer with feedback on Turbo TDP that direct messages Matthew Track Lead or Samantha Track Lead on Slack will be the winner. The light fixture bracket and challenge coin requirements will also be in Turbo TDP. All coin designs must be received by noon Eastern Thursday. Lighted Up participants now have 2 weeks to print the part and document their efforts in a TDP to accompany the part along with a video diary of the prototyping process. All parts must be received by April 9th.
So rev up your printers, launch your design software, and bring on your scavenger hunting skills as we hack the machine.
All right. It sounds like all of you joining us online really have your work cut out for you, and you've heard from the other leaders that we have here with us from Naval Sea Systems Command that they're eager to do something with what you discover. One quick admin note. You heard about Turbo TDP from our Track 3 team. They'll be doing a Q&A session at 3 p.m. Eastern today in Slack in order to make sure everybody's logged in and good to go there. Okay, now that we have introduced the tracks, let's bring on the Chief of Naval Research to get this competition started. Through funding and collaboration with universities, government, laboratories, nonprofit organizations, and industry partners, so pretty much events just like this one, the Office of Naval Research maintains the future of naval power and the preservation of national security. Rear Admiral Lloyd Selby leads the Office of Naval Research and is one of the senior officers that will help us transform insights from Hack the Machine into action. That's great, sir.
Awesome. Over our man.
It's great to have you. Stay your feet away.
Do I have to stay here? I mean, Zach, I mean, you were just getting too big for your britches. He's got a teleprompter down.
I know.
I mean, I don't know what's going on with you and your hair. I mean, what the heck?
I know. I went COVID flow. I feel like I'm gonna invent some invent. If somebody can 3D print me metal scissors, I will cut my hair on camera.
Ooh,
that'll be a thing.
There is a challenge. That's a hack if there's one. I think your team's going to do it for you.
They might. I feel like I just got myself teed up somehow.
That's awesome.
Sir, we've heard all about like 3 really interesting, innovative challenges, and you and I have had conversations like this all the time, but for everybody online, and we've got like almost 800 people out there already, and they're still clicking in. Tell us why creativity and new ideas are so important to rethinking naval power.
Yeah, so I've been telling my folks since I came into the job last May, I think our role is, it's not just the future of naval power, it's really to help reimagine naval power. And I think this is a pivotal time in history. And a lot of people, including senior leadership, DOD and DON, Department of Navy, Department of Defense, sorry for the acronyms, are saying that this is a critical decade, that if we don't turn things around in this decade, that this century could be lost. Okay, and I'm talking about primarily countries like China. Okay, that could, and this is not just defense. This is our entire economy. This is our entire tech ecosphere. All of that could be lost. And I don't know about all of you, but I certainly don't want that to happen. Our ways of life, our economic prosperity, it's all kind of hinged upon a lot of these technologies. And so I think this is a pivotal time in history. We've got to get these technologies, move them faster from the idea, the concept, to an actual thing, product, something we can give in the hand of either a warfighter or someone in our economy. It's critical. It's a pivotal time.
Well, sir, you mentioned that balance between our economy and our military. But the Office of Naval Research covers that whole ground.
Absolutely.
And I mean, I want to make sure everybody understands that there have been some amazing inventions, that have come out of ONR that have benefited the world. Not just
gallium nitride in your freaking iPhone.
Right.
All those kind of products were things that ONR was pivotal to the research that actually perfected those kind of things that are now in from your Blu-ray disc player, your flat screen TV, to your cell phone. Those are technologies that came out of O&R sponsored research.
Right, and I mean GPS, everybody knows GPS. That came out of y'all's office as
lasers,
well.
I mean, just things that we did in the early days with the computers. I mean, one of our first things we did back in the early 1946, 47, early days of O&R was computer technology in partnership with MIT. In fact, I'd like to tell a story. There was a project we did, it was Project Whirlwind, and that actually became the backbone for what became the Whopper. You remember the Whopper? Remember War Game?
Yeah. Oh,
right?
yeah,
The
yeah,
movie,
yeah,
right?
yeah, yeah, right,
the big computer at NORAD that ran all the missile defense. That actually was Project Whirlwind that became that kind of backbone of that system that provided that North American air defense capability, and became the Whopper in that movie. But, so I always joke about that.
That's cool, sir. Something you mentioned earlier, I want to skip back to.
Yeah.
You mentioned speed.
Right.
And we've seen like systems take longer and longer and longer to be developed. So as you're reimagining and rethinking naval power and rethinking the way the U.S. technology base, I mean, tell us why speed matters.
Yeah. So agility, speed is critical because again, all these technologies racing at just a feverish pace. It continues to. It's not. I mean, people argue if Moore's Law is still in play or not. It doesn't matter. Things are still going at a breakneck pace. Our ability to consume that technology has slowed down. It's bogged down. And that's not the case in other parts of the world, particularly China. In fact, I just watched a video. So actually, an alum from this event in Boston several years ago continues to send me emails with ideas. And he sent me this link to a video called Shenzhen Province, the Silicon Valley of China. Hour and 7 minutes on YouTube, worth the watch. And it's just showing how rapidly they can iterate. You can walk through Shenzhen Province, and there's these electronic markets where they're not selling like finished products, they're selling circuits. They're selling power supplies. They're selling components of computers, fans, all the stuff you need. And people have maker marts in that same area where they're making stuff in like a month, coming up with a new cell phone or a new Alexa for your desktop. We can't do that even close to that pace. Even outside of DoD, even just in the normal ecosystem of our Silicon Valley is even bogged down. We have got to reinvent, reimagine our processes and changes. So when I tell people reimagine naval power, it's not just about what's the thing we're going to buy, what's the ship look like or the unmanned system look like in the future. It's also process. What processes do we have to actually go change and modify to allow us to go faster? Some of this is structural change we have to make, I think, to our entire system because we're structurally aligned, kind of like back in the 80s, right? And it worked really well back then because we had a tremendous lead over, at the time, the Soviet Union. And it was such a tremendous lead that I think in some respects, we kind of just rested, right? While others did not. Well, it's no longer the case that we have this tremendous lead. It is much, razor thin margins today. In some cases, maybe in some tech areas, others may be ahead of us. That should concern all of us. So we've got to change these things, these processes, these structures to get the agility back to go faster.
So we've got to go fast. And let's talk about how broad this challenge is, right? So we're doing maritime, cybersecurity, data science, and manufacturing, which sound like very different things. But you've talked about a digital thread that runs all through this, and digital engineering. So kind of show us how this is one holistic effort and not like different things.
Yeah. So go back to the days of old, which is not that long ago. People like me. But so blueprints, right? You had a design. You may have written literally on the back of a napkin or back of an envelope. Had an idea. You took that to maybe some kind of a schematic that you did on a drafting table, and you designed something, and then that would go to a bunch of engineers would have to now do the, how do I build a specification to go build this thing, whatever the thing is. Then it goes to some build process where they, again, may take maybe still a blueprint, and maybe now they fat-fingered into some kind of manufacturing device, the lathe, the drill press, the thing is going to go make and manufacture the component. That took time. Now, back when I was younger, didn't matter. That was fine, and you got a great product.
That was fast enough for them.
Fast enough. Today, not so much. So today, we know the digital tools are there. We've got the high fidelity, three-dimensional design tools. We've got all that stuff. The problem we have today is we do things in stovepipes. So we may do phenomenal design work in this stovepipe, designing the future submarine or surface combatant or whatever it is. Then you have to then take that product and literally convert it into a Word document specification to specify what you want the contractor to go build for you. The contractor then takes that written specification and develops their own model using their own very sophisticated, exquisite three-dimensional design tools to go build it.
May or may not have been the one you used.
Which may or may, probably wasn't, in fact, is what we find out. And then they have to convert it into their basically manufacturing tool sets.
Right.
That needs to be streamlined so it's one continuous thread, including once it leaves the manufacturer and put in the hands of a sailor or marine to support it throughout the life of that component. I now need digital OQE, objective quality evidence, to be able to change it, modify it, modernize it, maintain it. And I need to develop things like, the digital twin people talk about. We need to develop those kind of tools. We have to have modeling sim to validate how the ideal system would operate in an ideal world and compare it to what the real system is doing in the real world. And look for divergence. And when you see divergence, go figure out why. Yeah. Is it a material failure? Is it I'm just operating in a different manner? Figure that out. And if it's a material issue, then solve it. But don't just do it every 6 months or every year because that's what the preventive maintenance schedule says for the average of the entire class of components. Let's do it for that actual component. Give it a personality, a persona, and treat it that way.
So that we're continually updating, so it's not this big milestone separated.
Right, because right now you tend to go through these valleys of nothingness, big modernization happens, nothing. It's got to be continuous. And that way you can actually be set up to actually on-ramp technologies far faster. And kind of when they make sense, when the technology, not when the next modernization is 3 years from now, but when the technology is ready.
Oh, so we kind of break the scheduling paradigm.
Absolutely.
So instead of scheduling for, well, we have an opportunity to do the install here, we'll just wait until we get that opportunity. We have an advantage here.
Can I on-ramp it now?
Okay.
Right?
Yeah.
And some things you may have to wait, depending upon how extensive the repair or change is, but there's a lot of things that are just software-based. Those should be on-ramp all the time. This is where you get into DevSecOps and the continuous delivery kind of model. We've got to get that.
Admiral Rothenhouse mentioned that they're working on DevSecOps out there, and we know NAVC is as well.
Yep, as are we, and we're helping both organizations do that. So,
yes, sir.
Yeah.
Well, sir, we've got a lot of people out there that are inspired by these three challenges. You're always been, and will continue to be a change agent for this.
This is my fourth Hack the Machine event, right?
Yeah, you've been with
Boston, Seattle, New York, and now this one,
and now here, and now virtual. Yes, sir.
This is awesome.
That's great.
Fantastic.
Well, you're going to come back. We're going to see you in the mornings for a quick
tomorrow,
check-in.
the next day, and then for the awards ceremony
on Friday.
Absolutely.
Sir, you've been a supporter for years.
Yeah.
We know you're a forward thinker. We also know that you're going to help us do something with the things that people research.
Yeah,
so
that's
thank you
critical.
for coming again, and we'll check in the morning.
Yeah, and this is fantastic. So for all you hackers out there, have a great time. Enjoy this event. This is phenomenal.
Yes, sir. Thank you very much.
Awesome.
We'll see you.
Great to see you.
Take care, sir. All right, that was as always, an inspiring, dynamic discussion with Admiral Selby, the Chief of Naval Research. And as you can hear from everybody we've had on the program thus far this morning, what you do matters. People are looking for your ideas so we can actually get started. So now it's over to you. And I've got Nicole back with me. Nicole, what do the teams need to do at this point?
Do you think I could actually compete in track 2 and do this?
I think you could probably do anything you wanted, but please don't.
All right. So we'll just do this. So Zach, as the contestants learned from our track leads earlier, it's time to join a team and get started. So we'll see you on Slack, again, our official communications channel, to answer your questions, to release the data, and start the challenges. Be back here tomorrow at 11 a.m. Eastern to see how your track scoreboard is doing and hear insights on the first day of competition. All right, let's go hack the machine.
Let's go hack the machine.
Yeah.
Thank you.
Oh, this is great. I'm excited.